Hello everyone. In this video, the limit of a function is to be discussed. First of all, what's a limit? A limit of a function is the value that the function approaches as its variable approaches a particular number. So before we can say that a particular number or value is the limit of that particular function, we have to first look out for the left hand limit and the right hand limit. Now, what's the left hand limit? The left hand limit is the value that the function approaches as its variable approaches a particular number from the left hand side. Now, for this example, let's first check whether the limit of the function exists at 0. Now, from what I said earlier, we have to first check for the left hand limit and the right hand limit. If the left hand limit is equal to the right hand limit, then we can say that the limit of this particular function exists at x equals 0. Now, first of all, let's check for the left hand limit of this particular function. Now, limit as x approaches 0, the minus means that like left hand limit. So if we are approaching 0 from the left hand side, we meet values like minus 0.1, minus 0.001. So we can take any of these values and put it into the function. So we have 2 minus 0.001 plus 1. So with this, we have our function to be equal to 1. So the left hand limit of this particular function is 1. Now let's look for the right hand limit. So we have limit as s approaches 0 from the right hand side. So when you're approaching 0 from the right hand side, you meet values like 0.1, 0.001. So you can use any of these values to put into the function. So I'll go for 0.1. So when I put 0.1, or let's say 0.01 into the function, I have 2 times 0.01 plus 1. With this, I have 1.002, which is approximately 1. So here I can say that my left hand limit is equal to my right hand limit. So here now I can say that the limit of the function is 1, because the left hand limit and the right hand limit are equal, and they are all equal to 1. Now let's move to the next example. We have f of x to be equal to sine x over x. So limit of this as x approaches 0. So now, first of all, let's look out for the left hand limit and right hand limit to determine whether the limit of the function exists at x to be equal to 0. So with the left hand limit, so x approaches 0 from the left hand side, I have sine minus 0.01, then minus 0.0001. So here I have 0 over 0. Now 0 over 0 is indeterminate. So anytime you have an indeterminate, this is what you do. You differentiate the numerator and the denominator. That's the L'Hopital's rule. So now, when we differentiate sine x from sine to cos, we have cos x. And we differentiate x, we get 1. Right, so now when we put in our left minus 0.01 we have 1 minus 0.01 is approximately 0, so cos of 0 is 1. Now let's come to our right hand limit. So with the right hand limit, we are approaching x from the right hand side. So we have sine, let's say 0.01 over 0.001. So here we have 0 by 0, which is also indeterminate. So we have to apply the L'Hopital's rule. So we differentiate the top and down. So if I want to differentiate sine x, I'll get cos x. If I want to differentiate x, I'll get 1. Now when I put in 0.001, 0.001 is approximately 0. So I'm going to say cos 0. So cos 0 is 1. So now you can see that our left hand limit, which is 1, is equal to our right hand limit. So the limit of this function is 1. So now we've been able to determine that the limit of a particular function is found when the left hand limit is equal to the right hand limit. If the left hand limit is not equal to the right hand limit, then the function or the limit of the function does not exist at that particular point. So this is where we end for the limit of a function for